All right, here we go. Geometry 5-2, perpendicular and angle bisectors. Today, in this lesson, we're going to use properties of perpendicular bisectors and angle bisectors. Okay, first thing we're going to look at, using properties of perpendicular bisectors. This is a good example. You're going to hang a bulletin board over your desk using string. The bulletin board is crooked. When you straighten it, what type of triangle do you make? So you're going to pull this thing and make it straight. And it is going to be parallel to the ground when you get done. So your bulletin board is going to look something like this in black. So what are some things we can probably guess? Okay, we can probably guess those sides are the same. We can probably going to say it's perpendicular. So when we do that, we know these angles got to be the same because of isosceles triangles. So we've got some congruent triangles here. We've got a perpendicular bisector, don't we? So, in Solve It, you thought about the relationship that must exist in order for a bulletin board to hang straight. So the question is, what are the properties of perpendicular bisectors? Well, in the diagram below, CD is the perpendicular bisector of AB. CD is perpendicular to AB at its midpoint, all right, at point D. The diagram at the right, CA and CB are drawn to complete two triangles. And we're able to prove congruency of those two triangles by side angle side. So we should recognize from our work that triangle CAD is congruent to CBD, like we said, with side angle side. So we can conclude that CA is going to be congruent with CB. Okay, or we can say they're equidistant. Okay, point C is equidistant from A and B. Point C is equidistant from A and B. So here are some theorems about perpendicular bisectors. Make sure you understand this, rewrite this if you need to. All right. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So here's the wording of it. If segment PM or line PM is perpendicular to segment AB and MA is equal to MB, which is the definition of perpendicular bisector, then any point on point PM is going to be equidistant. So point PA is equal to, or segment PA is equal to segment PB. The converse is this. If a point is equidistant from the endpoints of segments, then it is on the perpendicular bisector of the segment. So if PA is equal to PB, then we know it is on the perpendicular bisector. So how does that help us solve some things? What is the length of AB? Okay, so we know AB is 4x, and we know BC is 6x minus 10. Well, we know from just looking from inspection, point BA must be equidistant to BC because BD is the perpendicular bisector of AC. So we can say 4x equals 6x minus 10. So let's subtract 6x to each side. So we're going to get negative 2x equals negative 10. Divide each side by negative 2. X is going to equal 5. Okay, but it didn't ask us for x. It asked us for the length of AB. So let's plug it back in. So 4 times 5 is 20. So segment AB has a length of 20. And that's exactly what the book got. What is the length of QR? Well, what do we know right now? We know QS is the perpendicular bisector. So we must know, without a doubt, PQ is congruent to RQ. So I got 3n minus 1 equals 5n minus 7. So let's subtract 3n to each side. We get 2n minus 7 equals negative 1. We're going to add 7 to each side. So we're going to get 6 equals to 2n. So n equals to 3. But again, it didn't ask us for the n. It asked us for QR. So plug that back in. So that's going to be 3 times 3 minus 1. So that's 9 minus 1. So that is going to be 8. So the length is 8. Okay? So next problem. A park director wants to build a T-shirt stand equidistant from the rolling roller coaster, which is over here to the left, and the spaceship chute. So what are the possible locations of the stand? Well, we want it to be equidistant. So the first thing we got to do, let's go ahead and draw a line from the roller coaster to the shooter. All right, the next thing we're going to do is we're going to use our compass, and I've already got some circles drawn. We're going to draw a circle around the roller coaster, and we're going to draw one around the spaceship chute, if we can get that. There we go. And once I do that, I'm going to be able to find a perpendicular bisector. Okay, now I'm going to draw a line. Maybe. That's going to be my perpendicular bisector. All right. That is close to being a perpendicular bisector. Not sure if it is or isn't. All right. But anyway, so anywhere on that line should be equidistant based on the definition. All right. Because that's the perpendicular bisector of the line. So again, that line that we just drew, I'll highlight it, this one, should be equidistant from the rolling coaster and the spaceship chute, because we found the perpendicular bisector. There we go. So moving on. The distance from a point of a line, okay? The distance to a point of a line is the length of the perpendicular segment from that point to the line. This distance is also the length of the shortest segment from the point to the line. In the figure at the right, the distance from A to L and from B to L represented by the red segments. In the diagram AD, the bisector is CAB. So if you measure the length of the perpendicular segment from the 2 points, from D to the 2 points of the angle, you will find that the lengths are equal. Point D is equidistant. Okay, so point D is equidistant. So here's our angle bisector theorem. If a point on the bisector of an angle, then the point is equidistant from the sides of the angle. If QS bisects angle PQR, SP and QP are perpendicular, then SR is perpendicular to QR. Okay? If that's true, then we can say segment SP is congruent or equal to SR. So the converse is this. If a point is in the interior of the angle is equidistant from the sides, then that point is the angle bisector. So if SP is perpendicular to PQ and SR is perpendicular to QR, then and SP is equal to SR, then QS is the bisector. Some nice little rules to have. So how can we use angle bisector? All right, well, we know by definition ray NR is the angle bisector of MNP. So what can we do? So we know segment MR and PR must be congruent, must be equal. So we can say 7x equals 2x plus 25. So 5x is going to equal to 25. So x is going to equal to 5. But it didn't ask for x, it asked for RM. So 7 times 5 is 35. Okay. So next example, what is the length of FB? Well, CF is the angle bisector, so BF and FD are congruent, so we can say BF is congruent to DF. BF is 6x plus 3. FD is 4x plus 9. So subtract 4x to each side. I get 2x plus 3 equals 9. Subtracting 3. So 2x equals 6. Divide by 2. So x equals 3. So as asking for BF. So 6 times 3 plus 3 is 18 plus 3, which is 21. So the length of FB must be 21. So DF is 21 as well. Okay, let's just double check some things. What is the relationship between AC and BD? Well, AC is the perpendicular bisector of DB. What is the length of AB? Well, AB's got to be congruent to AD, so AB's got to be 815. What is the length of DC? Well, DC's got to be congruent by definition to CB, so it's got to be 18. Okay, that's a quick synopsis of angles and bisectors of triangles.